Hi guys, Mr. Hill here with your maths lesson for today. We're carrying on looking at dividing two-digit numbers by one-digit numbers. Here are some questions just to get you started for the day. Press pause to complete your work. How did we get on with those? Some of them should be fairly easy. Some of them there might be something we've not come across yet. 21 divided by 7 is 3. Can almost do that one from our times table knowledge. 22 divided by 7 though. There's a remainder in there. There's one that we can't share. So if we've got a remainder, we'll put an R down and the number that's remaining afterwards. 34 divided by 7, can't do that. We've got a remainder in there again. So we've got 4 remainder 6. 35 divided by 7, we can do that. That divides equally. We can share that equally. Don't worry if you didn't get on with the remainders ones. We're going to cover that today. So that's going to be our learning for today. So our first question, we've got 75 divided by 6. How are we going to lay this out? What are we going to use to help us? I'm going to use the tens and ones. Now we could do this with the counters, or we could do it with the coins like I showed you yesterday. So if you've got those, that's brilliant. I'm going to show you how we're going to do it using the coins. The process is exactly the same if you're doing the counters. Let me just switch my cameras over. I'll be straight back. Okay, I've set myself up. I've got my question written at the top here, so I remember what I'm doing. 75 divided by 16. I've gone and got myself some coins. So I've got 7 tens, 1, 2, 3, 4, 5, 6, 7, and 5 ones, 1, 2, 3, 4, 5. I've set my grid up, so I've got my tens here and my ones here. First thing I'm going to need to do, starting with my tens, I'm going to put 1 10 into each row. Okay, I've got a 10 left over. So I need to exchange that for 10 ones. So let's see if we can get it to work again this time. There we go. I've exchanged my 110 into 10 ones. Now I can go back and I can carry on as we did yesterday. So I can take one of my ones and put it into each row as we go. So I'm going to keep going until I either finish down here with no coins left, or I don't have enough. I don't have enough coins now. I've got 6 rows down here. I've only got 3 coins left. I can't divide 3 by 6. So my answer is going to be, in each row, I've got 1 10 and 2 ones. So there are 12 in each row. So my answer will be written 12. And then I've got a remainder. So I need my R, and I've got 1, 2, 3 as my remainder. What we must make sure is if we've got more coins here than what we're dividing by, that's not correct. We can only have a remainder if the number left over is smaller than the number that we're dividing by. So to show you again using the counters on our screen, we're going to share the tens first. We exchange the 10 that's left. We share the ones. Before we do that, let's have a look at our part whole model. We've taken 60 out. We can divide 60 by 10. So we can use that as one of our numbers. So we've got that. We've taken 60 out. We've got left over 15. 15's not divisible by 6. 15 does not appear in the 6 times table, is the other way to think of it. So how close can we get? Well, we know from using the coins, we're going to get 2 in each row. We've got 3 left over. So on our part whole model, we'd count up, get as close to 15 as we can, counting in the number we're dividing by. So it'll be 6, 12. So that gives me 2. And then I've got the 3 left over. So I've got to 12, and then I've got 13, 14, 15. So I've got 3 more to count on. That's my remainder. So that was how I would use my part whole model to solve the same problem. So I've got 10 plus 2, remainder 3, gives me the answer of 12, remainder 3. So 75 divided by 6 is 12, remainder 3. Have a go at these ones yourself. See how you get on. Pause the video here to complete these. Right, here are your answers. So I've used a part whole model and I've used my place value chart for both of these. So 53 in my tens, I've got 30. I've taken those out. They've on the tens. I've exchanged the 2 tens remaining into my ones. That gives me 23. I've then gone and shared them as equally as I can. I've got 7 in each row, and I've got 2 that I can't fit into a row. So my answer is 17, remainder 2. 64 divided by 5, exactly the same. I've taken 5 tens, I've exchanged the 10 that was left into my ones to give, so I've got 50 is the first number I've partitioned off in my part whole model. That left me with 14. I've divided 14 by 5. I can do it twice, but I can't get to a third group because I've only got 4. So that will be my remainder. So my answer for 2, 64 divided by 5 is 12, remainder 4. If you've struggled a little bit with these, try it with the other method. So go back in the video, see if you can do it with drawing the counters out in your grid and follow along. So as I'm doing the one that we did with the coins, follow along and use the number you've got in and follow the process and practice it until you're comfortable with it. Once you're comfortable with it, come back and join us and we can carry on with the lesson. Those of you that are happy with this, let's move on. So I've got 17 divided by 5. Got my tens and my ones. Now, problem here. I've only got 1 10. I can't divide that by 5. I can't divide one thing and have it in 5 different places. So I'm going to have to exchange this straight away. So I'm going to take my 10 ones. I'm going to turn them into 17 ones. Then the process is exactly the same. It's moving them across, putting them in the right place. They're all ones. They're all going to go in the ones column. Here we go. Spread them equally. Now, I've done 3 in each row, but I've got 2 left and I've got 5 rows. So what's left over is smaller than the number I'm dividing by. So I can't share those last 2 equally. Now, to solve this, we go and count the number of ones in one row. There's 3. So the answer is going to be 3. And then there's 2 remaining. So it's 3, remainder 2. We can check this by counting in 5s. We've got 5, 10, 15. We've got 3 5s. And then to get to 17, 16, 17. I've got 2 as a remainder. So there they are, added onto my answer. So if our first number is not divisible by, if we're looking at a 2-digit number and our first number in that 2-digit number, so our tens number, is not divisible by the number we're dividing by, we need to exchange that into ones. 25 divided by 3. Your turn. Have a think. Look at the question, look at the numbers in it. Can you work it out? How did you get on? We can't divide 2 by 3. We can't divide our tens equally between 3. I've got 2 tens and I've got 3 rows. I can't do it. So I'm going to have to exchange those 2 tens for 20 ones. Let's do that. There we go. There's my 20 ones. So I've now got 25 ones on the screen. Need to sort them through. So I'm going to go one by one if we're doing this, drawing them out. So I know my first one, I've got 1, 2, 3, 4, 5, 6, 7, 8 in there. Second row will have 8 again. third row will have 8 again. So 8 threes, 3, 6, 9, 12, 15, 18, 21, 24. So my 8 threes makes 24. So 8 ones, 24. Then to get onto 25, I've got to add 1 more on. That's my remainder that's left outside. This one here. So my answer is 8, remainder 1. So this is why we need to make sure that we've shared things equally, that each group's got the same. And then if we've got something left over, we don't just think, oh, I'll just put it in that group there, it'll be fine. It won't be, because then we're not dividing properly. So if we have leftovers or we have a remainder, we must write it down as a remainder. How about this one? 55 divided by 5 equals 11. We know that. We know our 11 times table. We know our 5 times table. 56 divided by 5 is 11 remainder 1. 57 divided by 5 is 11 remainder 2. 58 divided by 5 is 11 remainder 3. 59 divided by 5 is 11 remainder 4. Can you see the pattern starting to develop here? 60 divided by 5 is 11 remainder 5. Am I right with that? What do you think? If you said I'm wrong, you're right. My divisor is the same as my remainder. So if you look at the other ones, so 59, 58, 57 and 56, the remainder is smaller than the divisor. Now, my remainder is the same as the divisor, so I've got an extra lot of 5 to add on. So let's work it through. I've got 60 there in my tens. So I'm going to share those out as I can. So I'm going to take those tens. I've got 5 rows. I can take 5 of my tens. I've got 1 10 left over. I need to exchange that to ones. I now need to share those ones. Let's do that. Now, I've shared it equally. There's no remainder here. So let's take the top row. There's 1 10 and 2 ones. That makes 12. So 60 divided by 5 is not 11 remainder 5. It's actually 12. So the remainder must always be smaller than the divisor. So whatever you're dividing the number by, if you've got a remainder and it's bigger or the same as the divisor, so the number you're dividing by, you need to add another group on or another lot on. Your turn. The remainder must be smaller than the divisor. Can you answer these 3 questions for me? Let's have a look. So reminding ourselves the remainder must be smaller than the divisor. So when we divide by 7, the largest remainder we can have is 6, because 6 is smaller than 7. When we divide by 4, the largest remainder we can have is 3. Again, 3 is the biggest number you can have that's not 4. When we divide by 36, the largest remainder you can have is 35. Okay, your turn now. Some questions on the board for you, or on the screen even. Work your way through. The talk to your partner bit. We're not in class, so you can talk to your parents or an adult. You could talk to your siblings, see if you can explain it to them, what they've done, how they've done it. You could explain it to your pet, or you could explain it to one of your toys. I don't mind which. I just want to have you guys having that conversation about how they've solved it. It'll help you understand better how this technique works, how this method that we're using will work. Pause the video to complete your work now. How did we get on? Does your pet know how to do division now using a place value chart? Ready for some answers? Here we go. Pause the video here to check your answers. How did you get on? If you got a few wrong, maybe go back and watch the beginning of the video again. Just have a practice through, get the method really solid in your head. If you need to go back, do that now. And when you've caught up again, join us and we'll carry on. Dora's been working out some divisions. 72 divided by 4 is 18. 73 divided by 4 is 18 remainder 1. 74 divided by 4 is 18 remainder 2. 75 divided by 4 equals 18 remainder 3. I know that without working out, it must be that 76 divided by 4 is 18 remainder 4. Talk to your partner. So whether it's your adult, your sibling, your cat, your dog, your fish, or your teddy. Why does Dora think this? And can you explain to your partner why Dora is wrong? What answers did you come up with? The one I came up with, I think Dora thinks this because she spotted a pattern. The further we get away from 72, the bigger the remainder gets, but the whole number stays the same. Dora is wrong because you can't have a remainder of 4 when dividing by 4. Well done if you got that. Give yourselves a clap. Okay, let's move on and look at a little bit of reasoning now. So apples are packed in bags of 8. This is important, we need to remember this. There we go, 8 apples, that's how many goes in one bag. Dexter has got 91 apples. How many bags does Dexter need so that every apple is in a bag? Have a think. See if you can work this one out. This is a challenge for you guys. See if you can apply what you've learned today and work this one through. Press play when you're ready to carry on. The first thing we need to look at is our question. So apples are packed in bags of 8. And Dexter has got 91. And we need to put them into the bags. So my calculation needs to be 91 divided by 8. That'll tell me how many bags I need. So we're going to use our grid again. I've got 8 rows this time to show that I'm packing them into bags of 8. I've got my 91. So I've got my 10s and my 1s. So I've got my 90, I've got 9 10s, and I've got 1 1. I'm going to share my 10s first. So I can share 8 of them, and I need to exchange 1 more because I can't share 1 10 across 8 rows. So using our part whole model here as well, we've taken 80. That's our first part. We've got 11 left over. So exchange the 10 for 10 ones. Share the ones as best we can. There we go. And I've got 3 left over that I can't fit into a group, so that's my remainder. So how many bags does Dexter need? We've got the answer there, 11 remainder 3. Dexter needs 11 bags, doesn't he? What do you think? If you said that I was wrong, then once again, you're right. The question asks us to make sure that every apple is in a bag. So we're going to need 1 more bag for those last 3 apples. So this is where you need to be careful with your division and reading the questions really carefully and really closely. It doesn't ask us how many bags of 8 can he fill and what will he have to carry in his hands. It asks us to make sure that every apple is in a bag. So I've got the 3 remaining. So I'm going to need 1 more bag. So the answer is actually 12 bags. Well done if you got that. Remember this for next time because we're going to be carrying on working through with our dividing. Right. Take this new bit of learning and see if you can get it to work out for these. See if you can apply it. If you need to, go back and re-watch that bit and take the numbers that you've got from this and use them in the calculation we've just done. Pause the video now to complete the work. Okay, you ready for some answers? Let's look at question 5. Eggs come in boxes of 6 and Annie has 76 eggs. She wants to know how many boxes she can fill. Complete the division to work it out. So our division is 75 divided by 6. It gives us an answer of 12 remainder 3. What did the remainder represent? It's what's left over. It's what can't go into a full box. So Annie can fill 12 boxes. So that's 12 boxes completely full with 6 eggs. And she'll have 3 eggs left over. Question 6. Jack has these bulbs. He has 49 daffodils, 63 tulips, and 98 crocuses. Equal numbers of each bulb are put into 4 tubs. How many of each bulb will be in each tub? So we need to divide each number by 4. So we have 12 daffodils in each tub, 15 tulips in each tub, and 24 crocuses in each tub. Working this through, to work out how many will be left over, we need to know that 12 times 4 is 48. So there'll be 1 daffodil bulb left over. For the tulips, there'll be 15 in each, with 3 left over. So that gives us 60. So 4 times 15 is 60. 63, take away the 60, will give us 3. Crocuses, 24, with a remainder of 2. So 24 times 4 will give us 96 crocuses used, with 2 left over that don't fit into any of the tubs equally. How many tubs could Jack use so that there are no bulbs left over? Now this is a trickier question. We need to think about things we've learned previously. So let's move on and I'll talk you through how I worked out the answer. Here's our question. Jack has these bulbs, so we know he's got 49 daffodils, 63 tulips, and 98 crocuses. How many tubs could Jack use so that there are no bulbs left over? So my way of doing this was I found the factors of each number. And then I found the highest common factor. Now, if you look at 49, we know that's 7 squared, so 7 times 7. 63 is 9 times 7. Now 98 might be a bit more tricky because it's not in our times tables. So I went through with that in mind. So I'm using the times table knowledge that I've got. So the highest common factor was 7. So 49 divided by 7, as I said, is 7. So 7 squared makes 49, using my multiplication and times table knowledge to help me with my division. 63 divided by 7 gives me 9. And 98 divided by 7 gives me 14. So it's not in that in our times tables that we know, but we know we can partition the number down. So we can have 70 and 28. So if we did a part-whole model with 98, we can take 10 sevens off, which would be 70, leaving us with 28. And we know that 4 sevens makes 28. So we'd have 10 and 4. So that was my method of working this out. I'll look forward to seeing the method that you use to work this out in Tapestry later. Take care, everyone. Stay safe, and I'll see you again for our next maths lesson.